All right, ladies and gentlemen, welcome back. We are doing the problem that you should have done on your canvas here, so let's go ahead and get started. First of all, I noticed that this is an SSA situation, and that tells me that there could be multiple different solutions. So the first thing I need to figure out is how many solutions it has. I noticed that this angle is obtuse, and that A is larger than B. So when I look back at that chart, angle A is obtuse, and A is larger than B. Therefore, that this is going to have one solution, because one triangle can be made. So, this is going to be done exactly like we've done our previous problems. If this is A, B, and C, we're looking for angle B, angle C, and side C. Now, I can't find angle C or side C right now, because with your law of sines, you have to know one or the other. So the first thing I'm going to do is find angle B. So sine B over side 12 equals, and I'm going to do my A's, sine of 122 over 18. When we cross multiply, we get 18 times sine B equals 12 times sine of 122, which means that sine B equals 12 times sine of 122 all over 18. Now, this whole thing in your calculator is 0.332, which means that, excuse me, not sine B, that means that B is equal to the inverse sine of 0.332. which is 19.39. So the first angle here is 19.39, and because I know the interior angles add up to 180, I can subtract these two angles to find out angle C. And that turns out to be 38.61. So this angle is 38.61. And now, since I have angle C, I can find side C with another law of sines. This is the sine of 38.61 over C. And then I'm just going to use this A ratio again, the sine of 122 over 18. When we cross multiply, the C ends up being sine of 38.61 times 18. And that's all over the sine of 122, which when you throw that into your calculator, you end up with 13.24. All right, again, if you've got questions on law of sines things, make sure that you were asking them. But let's look at our next examples with 0 solutions and 2 solutions. So this first one is going to have 0 solutions. And again, I'm noticing here that this has an acute angle, which means, going back to my chart, I need to calculate this h, right? The height has a lot to do with this. So I need to calculate b times sine A. So h equals b times sine A, which is 5 times sine of 51. And that calculation ends up being 3.89. And so here I'm noticing that h is greater than A, right? 3.89 is bigger than 3.5. So looking at my chart, h is greater than A. That means no solutions. Because if this is the height, well, if the A value is smaller than the height, then it's going to not reach the bottom of this triangle to form a triangle. So it can't work. So this one has no solutions because the height is larger than the A value. No solutions. Let's look at something that's going to have 2. Again, I'm noticing that my angle is acute, which means I need to calculate the height. In this case, it's 16 times the sine of 40, which is 10.3. So I'm noticing here that h is smaller than A, which is smaller than b, right? 10.3 is smaller than 13, which is smaller than 16. That means that this has two solutions. So what we need to do when we've got two solutions is make two triangles. And those two triangles, triangle 1, T1, and triangle 2, T2, we determine by what angle B is. Now, we have enough information to find angle B, because one of these triangles is going to be an acute triangle. And so with angle A being 40 and angle B being unknown, we can find this angle using law of sines. So let's do that first. Sine B over 16 equals sine 40 over 13. And again, this step is the same as the problem we just did. We're finding that law of sines. Cross multiplying, we get 16 times sine 40 all over 13. This bit in your calculator here ends up being 0.7991. So B then is the inverse sine of 0.7911, which means it is 52.3 degrees. So I have a triangle here. This is 52.3. I can find the C by taking 180 minus 40 minus 52.3. So my C angle is then going to be, I have it calculated here somewhere, 87.7. There we go. And then we can use that to find the other side. So we will do that in just a moment. But let's talk about this other triangle. We can have two triangles when we get two solutions. Look at our chart. We can have an obtuse triangle with this angle being obtuse, or we can have an acute triangle like this. Now we found the acute triangle. The obtuse triangle, the way we find it is we take 180 minus whatever this B was, 52.3. So the angle on the second triangle is 127.7. So here's what the triangle looks like, right? I've got a very wide angle here. This A value is the same. That's still 40. This B is 127, which means 180 minus 40 minus 127.7. This angle down here is going to be 12.3. Now again, I got this angle by taking what we measured B and subtracting it from 180. That's the obtuse angle. I have an acute one and an obtuse one. So just like before, I can now find the C value by completing law of sines. So let's go back to triangle 1 and do it here. I need to find the C value. Angle C is 87.7. So this is sine of 87.7 over C equals, and we'll just use A again, sine of 40 over 13, which means my C value is, let's see here. It's going to be a sine of 87.7 times 13 all over sine 40. And when you do that up in your calculator, you end up with C equal to 20.2. For our other triangle, it's going to be, again, we're finding C, so it's sine of 123, actually it's 123 point, I'm sorry, it's 12.3. I'm looking at my thing wrong, sorry. So this is sine of 12.3 over C equals take my a's again, sine of 40 over 13. So my c value is that sine of 12.3 times 13 all over sine of 40, which when we throw into our calculator is 4.3. So moral of the story, 2 solutions means that I'm going to calculate the b and find this first angle, right? That one gives me triangle 1, and I solve triangle 1 the same way we've been doing it all lesson. Triangle 2 I find by subtracting this acute angle we found from 180 to find the obtuse angle. Then I solve that triangle the exact same way that we've been doing it all lesson. All right, I've got a practice for you back on your Canvas. Please go check those out, and then we'll see you in the last video.